Welcome to aminacademy.com. In strength of materials regarding elastic constants, let us discuss about volumetric strain. The ratio of change in volume to the original volume of your body when the body is subjected to a single force or a system of forces is called volumetric strain. It is denoted by EV. Now, volumetric strain equal to a ratio of change in volume over original volume when subjected to a single or a system of forces. Now mathematically we can say volumetric strain EV equal delta V by V, where delta V is change in volume, V is original volume. Now let us discuss regarding this volumetric strain of a rectangular bar subjected to which is subjected to an axial load P in the direction of its length. Here, look at this figure. Here, a rectangular box, that is rectangular shaped bar, metallic bar is given here, which length is L, breadth is B, and depth is D. Now, delta L is change in length, delta B change in width, delta D is change in depth. Now, therefore, final length after deformation of the bar equal L plus delta L. Final width of the bar B plus delta B. Final depth of the bar D plus delta D. Now, original volume of the bar we know that volume of cuboid is L B D. Final volume after change in volume, final volume is L plus delta L into B plus delta B plus D plus delta D. Now, by multiplying same time ignoring the product of small quantities. That means we are ignoring, for example, delta L into delta B and delta B into delta D, like these very small quantities are ignored. Then we can write this multiplication becomes like L B D plus B D delta L plus L B delta D plus L D delta B. By the time ignoring the products of small quantities. Now change in volume means final volume minus original volume equal final volume minus original volume, which is equal, change in volume means delta V equal LBD plus BD delta L plus LB delta D plus LD delta B minus LBD, the original volume. So LBD minus LBD cut, therefore we can write delta V equal BD delta L BD delta L plus LB delta D plus LD delta B. Now volumetric strain is equal, that is EV equal delta V by original volume, which is equal, delta V is BD delta L plus LB delta D plus LD delta B over LBD. Volume is LBD. Now distributing the denominator everywhere, that is BD delta L over LBD plus LB delta D over LBD plus LD delta B over LBD. Here BD cut, here L and B cut, here L and D cut. Now the remaining things is delta L by L plus delta D by D plus delta B by B. Here this expression, that is bad, we know that delta L by L equal longitudinal strain, because change in length by original length. Longitudinal strain and longitudinal strain and and delta d over d, or delta b over b, or lateral lateral strain. Therefore we can say EV, volumetric strain, is delta L by L, that is longitudinal strain plus 2 times, because here delta D by D and delta B by B are equal, 2 into lateral strain. Longitudinal strain by lateral strain. Now from this we can say EV equal longitudinal strain, take out common, into 1 minus but here before that, now lateral strain, we know now lateral strain is equal minus mu Poisson ratio into longitudinal strain. Longitudinal Poisson ratio, that is mu minus mu into longitudinal strain. Therefore we can write EV, volumetric strain, is longitudinal minus mu into another expression, longitudinal strain. Here, therefore, EV equal, take out longitudinal strain common, 1 minus 2 minus 2 into mu. So this is a expression of volumetric strain. Therefore, we can write in mathematically EV equal delta L by L into 1 minus 2 mu, where delta L is change in length, L is original length, mu is Poisson ratio, where here we can write mu equal Poisson's ratio. We have done. Please subscribe our YouTube channel.